Okay, this is the last lesson of this chapter, and we have yet another set of identities. You knew this kind of was coming because we did the double angle, and then we did the sum and difference, and then the double angle, and then the other part on that half sheet that you have is half angle identities. So what we're going to look at today for this first part, again, is kind of just looking at that misconception where, like, hey, I have this angle. What if I take half of it? Is it the same thing as taking half of the ratio? So if I kind of have that idea and take that thought, the sine of 90 is 1. So theoretically, if this were true, that we could just take half of the ratio, that would mean that the sine of half of 90, which is 45, is 1/2, which we know isn't true. Half of 90, again, is 45, and we know that the sine of 45 is really root 2 over 2. So these things are, it's not 1/2 of that, so that means that this does not work. We can't just take like half of that identity or half the ratio and call it good. So instead, we kind of have these complicated formulas today to talk about half angles. Notice that there are 3 half angle variations on the tangent of x over 2, just like there were 3 half angle variations on the cosine of x over 2, or cosine of 2x, excuse me. So there are different ways that we can go about that. These ones are definitely easier because then you don't have to worry about like this plus or minus thing on the outside. And as we're looking at that, that should kind of, like, you should be thinking, all right, well, I know that when we take the plus or minus, usually when we have that idea, we have to like decide what quadrant we're in, whether it's a positive or negative. And that's going to be true here too. We have to figure out what quadrant really x over 2 is in to decide whether we are having a positive sign value or a negative sign value, or likewise a positive cosine or a negative cosine value. Which why when we deal with tangent of x over 2, this one's a little bit harder to deal with because we have to like think about those quadrants, whereas these we don't have like a plus or minus. So when we actually evaluate and we get a positive or a negative, we're good to go. We don't have to worry about like what quadrant we're in. Of course, you can use that to check. So we're going to evaluate the tangent of 22.5, which obviously we can't evaluate. However, I know that that 22.5 is half of a known angle. So that's what we have to think of. Like, if I double this, is there an angle that we know that would work? So tangent of 22.5 doubled, or 22.5 doubled is 45. So that means that 22.5 is really 45 divided by 2. And once I have that, once I come up with an angle that I know that when I have it, I come up with like the angle that I'm trying to find, the one that I'm looking for, then I can apply my identities. So like this is now my x value in my identities, and it doesn't matter which one you pick. I'm going to pick, I don't even care. I'm going to pick this last one just because. So this means when I expand out, again, 22.5 is half of 45, so that's why I can use that and why I'm using now my known angles. That's going to be my x value, the 45. So I'm evaluating 1 minus the cosine of 45 degrees over the sine of 45 degrees, which both of those are angles that I know and ratios that I know. Cosine of 45 is root 2 over 2. So 1 minus root 2 over 2. And sine of 45 is root 2 over 2. And to simplify this, I'm going to get a common denominator on the top. So 1 minus root 2 over 2, this would be 2 over 2. So altogether I have 2, so this is 2 over 2. I'll have 2 minus root 2 over 2 all over root 2 over 2. And I can multiply by the reciprocal, so 2 over root 2. When I do that, my 2's will cancel. I'm left with 2 minus root 2 all over root 2. And then that's something that I'd have to rationalize. I don't have to multiply with the conjugate because that's not like 1 minus root 2. It's just root 2, so I can multiply top and bottom by root 2. On the top, I'll have 2 root 2 when I distribute that, minus root 2 times root 2 is 2, all over root 2 times root 2 is 2. And then finally, last but not least, that's something I can simplify as I see a lot of 2's in there, so I can divide the 2's here and divide the 2's here in those two separate fractions. So 2 root 2 divided by 2 is root 2. and minus 2 over 2 is just 1. So that's my final solution. And again, this is something where you can like actually check it in your calculator. You can plug in tangent of 22.5. You can plug in or type in root 2 minus 1 and see if you are getting the same value. So the idea here is every time you see like a 0.5 here, like you saw those actually in the double angle ones when you were working, like you had a more expanded version and then you were working backwards and doubled it. You're kind of doing that same thing, except you don't have like the expanded version of the identity to match up with. We're just evaluating 22.5, which we can't evaluate. So we know that that's half of a known angle. Same thing here, like if I am trying to find the exact value of cosine of 195, that's not an angle that I know. It's not something on our unit circle. That if I like find out what quadrant that in, which 195 degrees is in quadrant 3, that would be a 15 degree reference angle, which I can't do that part. But I do know that that's what I'm actually finding. I'm finding the cosine of this value that's in quadrant 3. And that's actually an important part, because when we match up like the actual half angle part, we need to decide if this is positive or negative. And for that, you have to look at the quadrant of this angle. So right now, before I even expand anything, I know I'm in quadrant 3. So my cosine of 195 should be negative. And this is just so I don't forget that later on when I get my answer at the end, I want to make sure that like I know it's negative. I should get something that's negative there. Okay, so again, this might be half of a known angle. So if I take cosine and I want to see if it's half of a known angle, I can double it. So 195 doubled is, so let's see, that should be 400 and is that right? So 200, 400, 410, I think. Oh, no, that's a lie. Should be 390. 195 doubled. Yeah. Okay, so 390. So that's where I am, which that is something that we know. So 390 is more than 360 degrees, which means I can find a coterminal. So 360 or 390 minus 360 gives us a 30 degree reference angle. So that's really what I'm looking for, is I'm looking for a, like since I know that that's 30 degrees, that's something I can evaluate. So really when I expand this out and I use my double angle or half angle identity for it, that's where I am. Cosine of x over 2 plus or minus the square root of 1 plus the cosine of that angle, which 390, all over 2. And 390 is, again, something I can evaluate. I'm just going to treat it as 30 degrees because that's my coterminal. And I know we just came up with, like, I know 30 degrees is in quadrant 1, so this is where it gets kind of confusing. Like, this is coterminal with something in quadrant 1, but my original angle, 195, is in quadrant 3. So my answer should be negative. Even though this answer is going to be positive, my whole answer that I have, this plus or minus, is determined by the quadrant of the angle, not the quadrant of your new your new x value, your new angle that you're looking at. You have to go back to the original. So negative square root 1 plus the cosine of 390, which is the same thing as the cosine of 30 degrees, should be root 3 over 2, all over 2. And we have to simplify that. So now it comes into like algebra, and this is, you know, sometimes this gets a little bit complicated. So I'm just going to ignore like this big square and just focus on like how I would simplify that. Just like how I would simplify this. It's the same steps. So I'd have to come up with a common denominator. This would be 2 over 2. So on the top I have 2 plus root 3 all over 2. And on the bottom I have 2. And that's really 2 over 1. So now I have a fraction within a fraction. I'm going to multiply by the reciprocal. So multiply by 1/2. So on the top now, I don't have a fraction anymore. Or I do have a fraction, but it's just dealing with this one. I have 2 plus root 3. And on the bottom, I have 4. And now to simplify that, we take the square root of the top, we take the square root of the bottom. So on the top, we have the square root of 2 plus root 3. All over the bottom square root is 2. So that's our final answer. And I know it gets a little complicated, or it looks a little bit confusing because we have like roots and side roots, which sometimes can, be a little bit more complicated to actually simplify. But overall, like the steps of actually simplifying this thing are the same as if there was not a square root. The key here again is that this 195 degrees is in quadrant 3, meaning my cosine should be negative. So that's why I have a negative out front. Even though my cosine of 390, which is the double angle, this 195 is half of 390, that thing is in quadrant 1. That's just used to find your whole answer, but this plus or minus is determined by the original. Okay? Okay, so let's do another one. This one is like one of those longer ones where we're finding everything. So right now I know that my sine of x is root 5 over 3. I know that my x value is in quadrant 4, and I'm trying to find sine of x over 2, cosine of x over 2, and tangent of x over 2. Well, there's really only one value or one thing that I can use for sine and cosine, so I'm going to write those out. Sine of x over 2 is the plus or minus square root of 1 minus cosine of x all over 2. And the cosine of x over 2 is plus or minus, the square root of 1 plus cosine of x all over 2. So that's what we have so far. Forgot my equals. Okay, so right now I have the sine of x, which I don't have any, I can use that over here when I come up with my tangent, which I'll look at in a second. But right now, in order to come up with my cosine and my sine of x over 2, I need the cosine of x, which I only have the sine of x. But I do know that the sine of x is a ratio that I can use to find the cosine of x, just like when we did double angle identities. So x is in quadrant 4. So I'm going to put in my values here. This is x. My sine is negative root 5 over 3. So I can use that to come up with my my value here on my x-axis, which is really my cosine value, or cosine that I'm going to use my adjacent. So 3 squared, I can use Pythagorean theorem here, 3 squared minus 5, so 9 minus 5 is 4. Take the square root, we should get 2 in positive. And you can double check. 2 squared is 4, square root of 5 squared is 5, 4 and 5 is 9, which is 3 squared. So we're good. So our cosine value then, cosine of x, is going to be 2 over 3. And that's helpful because that's what I need here. I need 2 over 3 and I need 2 over 3. So I can use that to come up with at least part of my half angle. And that would be here, cosine of x over 2 equals plus or minus the square root of 1 plus 2 over 3 over 2. Okay, so now you might be thinking, well, crap. Now I have x, I know that x is in quadrant 4, but I don't know anything about x over 2. In fact, we're trying to find that. We're trying to figure out what x over 2 is. We've actually done these problems a long time ago, back in chapter 2 or chapter 1, where we were looking at what happens if you double the angle or halve the angle or add 90 degrees to those angles, what that does to your actual quadrant. So we're going to figure out what the quadrant is of x over 2, and that will help determine whether we're positive or negative in both these things. Right now I know that x is in quadrant 4, so that's between 270 degrees and 360 degrees. And before we've came up with these boundaries and we made an inequality for it, that's how we tackled this in the past. I'm looking for x over 2, so in order to divide x by 2, I have to divide all of my boundaries by 2 as well. So this is 135 x over 2, and this is 180. Well, what quadrant is 135 degrees is 180 degrees? That's going to be in quadrant 2. So I know x over 2 is in quadrant 2. The other way you could do this is think of a test case. So pick an angle that you know is in quadrant 4, like 300 degrees. Divide that by 2, you get 150. That's sitting in quadrant 2. So you could do it that way as well, rather than like coming up with your boundaries. Just do a quick and easy test case. So since I'm in quadrant 2, that means my sign is positive. So that determines this and determines this. And that tells me I'm positive in my sign value and then negative for my cosine value. So let's simplify. On the top, if I'm going to simplify this, I'll have 3 minus 2 over 3 all over 2. So 3 minus 2 is 1, 1 over 3 all over 2. When you multiply by the reciprocal, so that's 2 over 1, you get 1/6, which is 1 over root 6. And then I could rationalize that, multiply by root 6 over root 6, and get root 6 over 6. So that's my sign value of x over 2. And I'm going to do the same thing for my cosine. So sorry, I went through that a little bit fast, but it's the same steps as the front. I have a negative in this case. When I come up with this common denominator again, like this is, I have to multiply by 3 over 3. So I have 3 plus 2 all over 3 all over 2. And when I rationalize this and multiply by the reciprocal, I'll get 5 over 3, and then we multiply by 1 over 2. So 5 over 6, which when I rationalize that, that's negative root 5 over root 6. And when I rationalize and multiply by root 6 over root 6, I get negative root 30 over 6. And that's for the cosine. Okay, so for my tangent of x over 2, I could use my identity, which isn't like the worst idea. Like I could use my identity to come up with these two things and then simplify it, or you could do sine over cosine. You just have to be a little bit careful when you do that, because you'll end up with something when you simplify it, it'll be like it's easier to simplify one way or the other, and we can go over that some more. I'm just going to use my identity, and I'm going to use this one here, the sine x over 1 plus cosine x. I'm running out of room. So my sine x I know is negative root 5 over 3. My cosine x, what I found out, was 1 plus 2 over 3. So negative 5 over root 3. Sorry, negative root 5 over 3, and then the bottom, when I come up with the common denominator, multiply by 3 over 3. I'll have 3 plus 2 over 3, so that's 5 over 3. And my denominators will cancel when I multiply by the reciprocal, and I'll get negative root 5 over 5 for my answer. And that's the tangent of x over 2. So again, I came up with my sine of x over 2, my cosine of x over 2, and my tangent of x over 2. And to come up with like these signs, I needed to find my quadrant first. So this is one where like when you come up with your quadrant of x over 2, like these ones you have to come up with your quadrant of x over 2 before you actually come up with your final solutions for sine, cosine, and tangent. Versus before when we did double angles, like we came up with our answers and then we determined the quadrant. This one you have to do the quadrant first. Okay, so same idea for this one. Like in order to come up with, like we're given a ratio, we have to find the cosine of x over 2. We only have one way to do that. Oops. It's the plus or minus square root of 1 plus cosine of x all over 2. Like that's the only way. Lucky for us, we don't have to draw a reference triangle because we're given the cosine of x. So plus a negative minus root 2 over 3 all over 2. This one, just the simplification is a little bit more difficult. And again, we have to like figure out whether you're doing plus or minus. So we're going to do that first. We know that x is in quadrant 2. So if I write my ratio or my boundary case for quadrant 2, that means I'm between 90 and 180 degrees, but I'm looking for x over 2. So I divide everything by 2 and I get 45, x over 2, and 90, which means quadrant 2, x over 2 is sitting in quadrant 1. Now again, you could come up with a test case instead. Like you could think of an angle in quadrant 2, like 100 degrees. You can divide it by 2. You get 50 degrees. That's in quadrant 1. So in this case, we're going to use the positive version here. But the simplification of this is a little bit more challenging because it's not something that was easily, like we weren't just dealing with numbers. Now we have a root in our answer inside our root, so it comes a little bit more complicated. On the top here, when I come up with a common denominator, I'll have 3 minus root 2 all over 3 all over 2. And same as above, I'm going to multiply by the reciprocal, so I'm going to multiply by 1 over 2. And again, this is the positive. So I have 3 minus root 2 all over 6. And above, we split this into 2 radicals. We took the square root of the top and the square root of the bottom, and then we rationalized. And here when we rationalize and we multiply by root 6 over root 6, we have like usually when we multiply roots and roots, we just multiply those numbers together. It's the same thing here. It's just we have to be careful because there's another root inside. So when we actually like multiply the insides together, ignore the square root. You're multiplying 3 minus root 2 by 6. That's what you're doing, like all under this big square root. So what that means is we'll have 3 times 6, which is 18, and root 2 times 6, which is 6 root 2. And then that's all over 6 root 6 times root 6, which is 6. And that's your final answer. And you don't simplify after that. Like you might be tempted to be like, okay, well that simplifies to 3 and that simplifies to 1. Nope, like that's a big square root. This is not. And so like the hard part here is to like actually get this down, that you don't, like you're not multiplying the roots here and getting 3 minus root 12. This is like taking, like if this were root 10 and this is root 6, you'd get root 60. You'd multiply those numbers inside. So you're multiplying this quantity by 6. That's what's happening. So you get that as your final answer. I think in general half angles are easier to deal with. Like this process of, like, again, it's a tedious process, but it's a lot easier to know like where to go. Like I know that I have this and I have a direct way where I'm finding like the simplified version of that. The hard part is actually like the simplification of it, the tedious algebra work. 2 more problems. These are verification ones, but again, they're like pretty straightforward. So in this case, we're coming up with we have the secant squared of x over 2, which we don't have in half angle identity for secant, but we do have one for cosine. So I'm going to change that to 1 over cosine squared of x over 2. And then that is, we looked at that above, like this is our cosine expansion, so plus or minus the square root of 1 plus cosine x all over 2. So what happens when we take this big square root that has a plus or minus and we square it, doesn't matter if this is positive or negative, when we square it, that'll go away, so we don't have to worry about that. The big square root squared will undo each other, so we're left with 1 over 1 plus cosine x over 2. And this is 1 over 1. When I multiply by the reciprocal, I'm left with this identity, 2 over 1 plus cosine x. So that's in general how you'll see a lot of these half angle identities happen, is that we're dealing with something squared, which since we have this whole thing quantity that's getting a big square root, when we square it, that whole thing will go away and we'll just be left with what's underneath the square root. So we'll do it one more time. Again, this thing we don't have an identity for. We don't have identity for cotangent. So we want to change it into our primary. So that'll be tangent squared of x over 2. And we want to end up with this on this side, which this is actually a little bit harder because tangent has 3 different versions that we're dealing with. So we have to pick one that makes the most sense. What I see is a 1 plus cosine on top, so I might as well like pick this one because that deals with the 1 plus cosine versus this one with the 1 minus. You could do it either way, but I think it's easier to do it that way. So we'll have 1 cosine over 1 plus cosine squared. Quantity squared. Which, when we distribute the square within this quantity, we'll have sine squared over 1 plus cosine quantity squared, which is good because that's what we need above. Like, we need this quantity of 1 plus cosine squared and this sine squared term. And again, when I multiply by the reciprocal, this thing will be on top, 1 plus cosine x quantity squared, and then this will be in the denominator. And then that's really what we want above. Okay, so again, like, I think the hardest part with half angle identities is that we're dealing with like a lot more simplification with our like big square root there. So it takes like a little bit more work and a little bit more to get used to this. But once you get that process down, again, it's not like a hard process. It's just a little bit tedious to actually get there. And so again, it's like this test coming up is something that you can definitely get like a really good grade on. It's something that if you do enough practice problems, you will like finish that test no problem, and you'll be able to like make sure all of your algebra is okay, and you can simplify, you know, as long as you can simplify these things, and that just takes practice to get there, then you should do well on this test.